All right, you guys, so today we're going to go ahead and review direct variation. So when I say direct variation, what I'm really referring to is an equation of y equals mx. So if you see something written as y equals mx, then it is direct variation. So let's break down that formula a little bit. When I say m, I mean slope. When I talk about slope, slope is really just your rise over your run. If you guys don't remember rise over run, then rise over run is really just your y point over your x point. So if that is our slope and slope is y over x, then m is also going to equal y over x. So let's go ahead and get started with number one. I'm going to recommend that you guys get a pencil and paper if you don't have one already. This one here says the cost of Y movie tickets, just give me 1 second, varies directly with the number of tickets X as shown in the graph. So in other words, the cost Y, so I have my X over Y, typically that's what it is, right? So in this case, my X would be my tickets, and my Y would be the cost, right? Let's see. Write a direct variation equation to represent this relationship. So when they say direct variation equation, they want something that looks like y equals mx. Okay. Then identify the constant of variation and intercept its meaning. So what we're going to go ahead and do is I'm going to point out these 2 points that are plotted right here. Right, I see my first one. If I go over 1 and then up, because I went over 1, that's my x, and then up, that's my y. So I have my first point of 1, 8, and then I have my other point. I have to go over 3, and because I'm moving along my x-axis here, we're going to go ahead and put the 3 for x. That's my run. Now I'm going to rise, so I'm going to go, up until I get to 24. So my y point is 24. Now I need to find my slope because my slope is going to help me find my direct variation. So if my formula for slope is y over x, then I'm going to look at my points. I have an x point and I have a y point. Okay. So my y is going to be 8 over my x point of 1. Now I'm going to ask myself, can I simplify 8 divided by 1? And I can. And so when I simplify, I'm just going to get 8. Now I'm going to go ahead and double check with these other points. I have 3 as my x point and 24 as my y. But when I'm solving for slope or solving for my m, I need to do y over x. Here my y is 24 over my x of 3. Can I simplify? 24 divided by 3 is going to give me 8. So I know that the constant of variation is 8. Now my formula. So this is also my slope. Now if my formula for my direct variation equation is, if my formula for my direct variation is if my formula for direct variation is y equals mx, remember my slope is m. So really, y equals, instead of m, I'm going to put what we found for our slope, which is 8, and then x will be just per the amount of tickets bought. So your formula is going to be y equals 8x. So let's give it another shot. If I look over here, the number of miles, y, varies directly with the number of hours x. Shown in the graph, write a direct variation equation to represent this relationship. Then identify the constant of variation and interpret its meaning. So once I look at my graph, I see that I have 2 points plotted. I'm going to go ahead and list those points. I see that my x is 3 and my y is 195. So just remembering that this is my x and this is my y. And then if I look at my other point right here, I see that I have to go over 6 and then up. And then when I go up, it gets me to 390. So for this ordered pair, I have 6 as my x point and y is my 390. So I need to find the direct variation, but in order to do that, I need to find the slope. So remember we said slope equals m, and to find my slope, I can do y divided by x. So let's give that a shot with our 3 and our 195. So I'm just going to plug it in. I'm going to do y, and if I look here, I'm going to see that my y is 195 over my x, and again, if I just look up here, my x is going to be 3. So I'm going to ask myself, can I simplify? And I can. So 195 divided by 3 is going to give me 65. I'm going to go ahead and just double check my work using my other point. So my slope is equal to y over x. M is equal to y over x. M and slope are the same thing. So here I have m is going to equal 390 because that's my y point from my second ordered pair, all over 6 because that's my x point from my second ordered pair. Now 390 divided by 6 is going to give me 65. So this is my constant of proportionality, This is also my slope, which is equal to m. So now when I write my equation for my direct variation, again, they're looking for something that's going to look like y equals m times x. Well, here I know what my m is. So my equation is going to be y equals 65 times x. All right, let's take a look at number 3. Number 3 says the cost of paper varies directly with the number of reams bought. Suppose 2 reams cost $5.10. Write a direct variation equation to represent this relationship. Then identify the constant of variation and interpret its meaning. So here I have the cost of paper varies directly with the number of reams bought. So number of reams bought and cost of paper is what we're looking at. So I'm going to have my cost as my x all over my number of reams, which is going to be my y. All right. So first, they tried to trick me up here because once I read through my problem, typically when I read through a word problem, there's not a whole lot of math that needs to get done before I can start solving my equations. But sometimes they'll throw in a little bit of math before you get started solving this equation just to throw you off. And that's what they did here. So if I go back and I read it, the cost of paper varies directly with the number of reams bought. This is what's important. So here they say, suppose 2 reams cost $5.10. So my very first thing to do is figure out how much 1 ream is going to cost me, right? So I have $5.10 and 2 reams are bought. Do you see how this is also lining up with my cost and my number of reams? So once I do 510 divided by 2, I'm going to get $2.55. So that is my constant of variation. Is $2.55. So when I write my y equals mx, this is also my m. So y is going to equal 2.55x. All right, let's go ahead and try one more. This one says the amount of flour needed for a recipe varies directly with the number of servings planned. So let's just read that through one more time. The amount of flour needed for a recipe varies directly with the number of servings planned. 3 servings require 4.5 cups of flour. Write a direct variation equation to represent this relationship, then identify the constant of variation and interpret its meaning. So the way that I'm going to set this up is I'm going to go ahead and look at how many cups of flour is needed, because right now what I'm going to be doing is solving my y over x. So this is going to be 4.5 for my cups of flour all over my x, which would be servings of 3. So once I divide 4.5 divided by 3, I'm going to get m equals 1.5. So my equation for this is going to be y equals 1.5x. So to go ahead and review really quick before we sign off, I want to just review with you the definition of direct variation. Direct variation is any equation written as y equals mx, where m is the slope. We know slope as rise over run. Rise over run is y over x. So therefore, whenever we see m, we know that m is going to be equal to y equals x. Whenever we're writing an equation for direct variation, the format that we want to use is y equals m slope times x. All right, you guys, thank you for watching. If you need any help on anything, go ahead and send me an email, and I will get back to you as soon as I can. Thank you, guys.